preparation for making a standard curve to relate absorbance to concentration, we are starting with the 2.5 times 10 to the negative fifth molar concentration stock solution of crystal violet. We're going to make some different concentrations of crystal violet solution by diluting with water. First one we're going to do, so to determine how to dilute a solution, you can take M1V1 equals M2V2. This works because molarity times volume is moles, and when you dilute, you are basically adding water, so the moles of solute stays the same from beginning to end. So we have the concentration of the original stock solution times the volume of stock solution. That's what we're trying to figure out, how much volume of stock solution we need. We want to make a concentration of 5 times 10 to the negative 6 molar, and we want to make 25 milliliters of that solution. So when I solve for V1, the volume of the stock solution that we need, I get 5 milliliters. So you can see over here that I have 5 milliliters of the stock solution measured out. And since I want a volume of 25 milliliters total, I'm going to add water to this graduated cylinder until it gets to a volume of 25 milliliters. Notice that as the concentration is going down, the color of the solution is much, much lighter. Alright, so I'm going to do a similar thing for our other three solutions. So for the next solution, we want to make 25 milliliters of a 1 times 10 to the negative fifth molar solution. So that means I will need 10 milliliters of the stock solution. So over here, I have 10 milliliters of the original crystal violet solution measured out. And again, I'm going to add water to get to a volume of 25 milliliters. So here's 15 milliliters of stock solution measured out. And we're going to add water until that gets to the 25 milliliter volume, so a total volume of 25 milliliters. Here you can see the 1.5 times 10 to the negative fifth molar concentration solution after I've added water. We're ready for our last dilution. This time, we're making a concentration of 2 times 10 to the negative fifth molar. Again, we're going to make a total of 25 milliliters of solution. So the volume of stock solution that we need is 20 milliliters. And you can see that in my last graduated cylinder, I have 20 milliliters of stock solution measured out. And I'm going to add 5 more milliliters basically to get to the 25 milliliter mark. Now that we've diluted all our solutions, you can see that as the concentration of the solution gradually gets higher, now it's a little hard to tell because some of these graduated cylinders are different diameters, and so the path length that we are looking at is a little bit different, but basically they should go from lightest to darkest as we go from lowest concentration to highest. Now we're going to take data using our colorimeter for the absorbance of each of these 5 different samples. And we're going to use that to relate the concentration, which we know because we've measured it, to the absorbance that is being measured in the colorimeter. All right, we're going to use this device. This is called a colorimeter. And notice it only has 4 options, 4 wavelengths. We have it set to 565 nanometers because that's one of the better wavelengths for detecting crystal violet. And we are going to use this little container. It's called a cuvette. Notice on 2 sides of the cuvette, where I'm holding with my fingers, it's kind of ridged. That's where you want to place your fingers. The other 2 sides of the cuvette are very smooth, and you want to avoid getting smudges and fingerprints on them. That's where the light in the colorimeter is going to shine through your sample. So the first thing you do when you're using a colorimeter, you plug it in, you let it get warmed up. So it's been plugged into my lab quest for a little while. We're going to make a blank. So I just filled this cuvette with distilled water, and I'm going to use a Chem wipe, which is a fancy tissue, to wipe down the 2 smooth sides and make sure we've gotten any smudges off of the cuvette. I'm going to put a lid on it, and I'm going to put it into the colorimeter so that the smooth side lines up with a little arrow that you can see inside of the colorimeter container. Maybe you can kind of see it's just printed into the plastic. And I'm going to shut the lid. And I'm going to hit the button that says CAL and hold that down. We're calibrating. Using a cuvette, to use the same cuvette for all your samples. Now, you guys aren't necessarily going to be able to use this exact same cuvette for your samples next time, but we're doing the best we can given our circumstances. So I'm going to rinse this out and I'm going to refill it with one of our samples. So we're going to start with the lowest concentration, although it doesn't really matter what order you do it in. I'm still holding onto my cuvette with the ridged sides, and I'm going to fill the cuvette with that first sample. You fill the cuvette about 2/3 full. It doesn't have to be filled to the brim, just high enough that the light's going to shine through your sample. I've got it filled up. I'm going to put the cap on. I'm going to place my sample in the colorimeter, lining up the smooth side with the arrow. Shut the lid, and we'll notice a reading. Wait till it stabilizes. So that reading, that absorbance reading, should go with this concentration of crystal violet. I'm going to continue. I'm going to rinse out this sample. Rinse my cuvette over my sink with the distilled water. And I'm just using the same cuvette for all my samples. That's best practice in case there's any smudges. We're doing it the same way every time. Now I'm switching to the next highest concentration of crystal violet, and I'm going to fill my cuvette up again. I'm still holding on to the ridge sides. Notice once you get it into these containers that are all the same path link, it's going to be really easy to tell the difference in concentration. I'm going to cap it. I'm going to wipe it with my Chem wipe just in case any drips got on it while I was filling it. Place it in so the smooth side's facing the arrow. Close the lid, and you'll notice my LabQuest starts reading an absorbance. You want to make a recording of that absorbance. Again, we'll repeat the process. Take it out, rinse it out. I'm going to move to the third sample that I made. This is 1.5 times 10 to the -5th molar. Cap it. Wipe it down and make sure I didn't get any new smudges on it. Insert it. Close the lid and wait for the absorbance reading to stabilize. Record my data. Rinse this one out. Next concentration is 2 times 10 to the -5th molar crystal violet. Rinse out my sample. Fill my cuvette up about 2/3 to 3/4 of the way full. Don't want to overfill it and spill inside the colorimeter. Where'd my lid go? There it is. Put the lid back on. wipe the cuvette down, put it into the colorimeter, close the lid, wait for the absorption reading to stabilize, record my data. And then one more data point to take. So for the last time, I'm going to empty my cuvette, rinse it to the sink. And this time I'm going to use the stock solution. This should be the darkest solution of all. So I got my cuvette filled up. Put this lid on one more time. Wipe down the sides so they're nice and clean. Place it in the colorimeter. Close the lid. And as a reminder, the concentration this time is 2.5 times 10 to the negative fifth molar. That was the original stock solution. It looks like the absorbance has stabilized. So we can take some data. Just to double check myself. I put a blank in. That absorbance is still 0, so that's a good sign. And you can use that as one of your points when the concentration of crystal violet is 0, the absorbance is 0, so that can be the 6th point in your calibration curve. So that should be enough data to get you started.